Hello, anyone there?
Hello, anyone there?
Point 8 to 1.4 होता है acceptable keratin level.
Hello, everyone. This is Jeff Barr coming to you from Seattle, Washington. I'm just about to get underway. I would like to make sure that you're able to hear me. If you can hear me, please let me know in the chat. All right, so let's go ahead and get started. As I said, my name is Jeff Barr. I am part of the Amazon Web Services team based here in Seattle, and I've been at AWS for just about 10 years. For that 10 years, I've held the position of Web Services Evangelist and then Senior Evangelist. As part of today's Bootstrap Week, I have been asked to speak to you about the Amazon Web Services. The intent here is that my presentation should take about half an hour, perhaps 40 minutes, and we'll have the remaining time to entertain questions. I think we'll do those via the chat window. So if you have questions, please go ahead and enter those into the chat window. I'll try to take a look at that as I'm going through my presentation, but most likely I'll hold off on the questions until the Q&A time. So thank you all for attending. This is the first time I've actually presented this particular presentation, and of course your feedback is always welcome. Just so you know who's talking to you, I do have a bachelor's degree in computer science from the American University in Washington, D.C., way back in 1985. I'm also a graduate student in digital media at the University of Washington. I've been there for the last 2 years part-time. Before coming to Amazon, I spent a couple of years on the Visual Studio team at Microsoft. During the first .com boom, I was a consultant to some startups and venture capitalists. And I joined Amazon.com in 2002 at the very, very beginning of our web services effort, which then turned into the cloud computing effort a few years later. I've written a book called Host Your Website in the Cloud, available at your favorite online retailer. Describes how to use the Amazon Web Services using PHP. You've got my email address and my Twitter handle there, and I would always be happy to chat with you privately. Okay, I have a request to mute the other participants. Let me go ahead and figure out how to do that. Give me just a second here. I'm going to go ahead and do that. If you are listening in, please go ahead and mute yourself. Would be the best way for us to avoid any background noise. I cannot actually hear the rest of the conversation, so I'm not aware of any background noise. Okay, there we go. I've muted everyone. All right, hopefully you can still hear me. There we go. Okay, so today I'm going to talk about the Amazon Web Services. I'm going to talk about the principal Amazon Web Service components, and I'm going to show you how they fit together. And then I'm going to talk to you about a higher level service that we have that's called the AWS Elastic Beanstalk. The Amazon Web Services product line was launched in 2006. It's been very successful for us, and we have hundreds of thousands of AWS customers in 190 different countries around the world. The idea of AWS is that we offer a set of building block services, and as you'll see, those are fairly concise, low-level services, and you generally have to put them together in a particular way in order to construct your application. The AWS is a self-serve based business model, and you can simply go to aws.amazon.com, create an AWS account, and sign up for that account with a credit card. The account is free to create, and you only pay for the services you actually use. The AWS platform is rich and complex and has a number of different services. In a full AWS presentation, I would probably spend about 10 minutes or so going through the slide, but in the interest of time, let me just summarize for you. At the bottom, we have the AWS Global Infrastructure. We have regions, which are collections of zones located at 8 different locations around the world. Each of these regions is effectively a collection of multiple data centers, and they're located throughout the US, Europe, Asia, and South America. Availability zones are a more fine-grained representation, and the idea is that you can scatter your application functionality across 2 or more zones in a region in order to have fault tolerance in case there was a failure that affected a particular zone. We have a content distribution network with over 30 edge locations worldwide. Building up from there, we have foundation services for compute, storage, database, and networking, higher level application platform services for content distribution, messaging, parallel processing, libraries and SDKs for a wide variety of different environments and languages. And at the next level up, visual tools, things like administrative console, identity and access management to regulate exactly who is allowed to access your different resources, deployment tools such as Elastic Beanstalk that we'll be discussing, and then monitoring tools to collect statistics and performance information about your application. So with all these different building blocks, you can architect and build an application, and you can pick and choose amongst these different services. Nothing mandates that you use all the services in a particular application. Most of our successful customers generally pick 1 or 2 services to build the first iteration of their application, and then they'll add some richness and complexity over time as they gain experience with the services. I'm going to be demonstrating to you a little bit later a really important visual tool we call the AWS Management Console. This is available to you as part of your AWS account, and as you can see, there are a set of tabs up there across the top. Each of these tabs gives you access to a different AWS service, and then within the tab you have additional navigational controls along the left to access different aspects of that particular service. I'll be showing this to you live in just a few minutes, but this is the basis for some of the discussion that follows, and did want to make sure that you were aware of its existence. One of our principal services is called EC2, the Elastic Compute Cloud. At the center of this diagram, you'll see that a little gray box called an EC2 Instance. This is a virtual server that you can launch on demand. And one of the really important models of EC2 is this idea that you can launch as many servers as you need, from 1 to 10 to hundreds to thousands. So some of our customers actually running tens of thousands of servers, either long-term or temporarily. The instances always run within a particular availability zone, and in turn, the availability zones are always in a particular geographic region. Now, there's a number of different ancillary aspects to this architecture. One very important one is called the Security Group. The Security Group is a virtual firewall that protects access to your instances. You can create and then use IP addresses to access your instances. And you can also use load balancing tools to spread a load across any number of different EC2 instances. When you launch a new EC2 instance, you always do that by referencing a particular AMI, an Amazon Machine Image. You could think of this as being the same as the boot disk of your local computer. It has your operating system, your development tools, your application, all burned on there and ready to go. When your instances run, they're constantly reporting metrics to our monitoring service, which is called CloudWatch. Those metrics can be used for a number of purposes. One of the most important purposes is driving another service called the Auto Scaling service. With the Auto Scaling service, you can designate a set of rules to say, based on the amount of network traffic or the load average or other metrics you might collect, you can then use auto scaling to scale up or scale down the size of your auto scaling group to respond to changes in situation. For example, if you're hosting a website on a group of EC2 instances, you could define a rule that says when the average network traffic out of a particular instance reaches some particular value, and you could use that value to basically know how busy that instance is. When it reaches a certain level, you'd like to add another instance to the group to spread the traffic out across a wider array of servers or instances. Auto scaling actually communicates with the load balancing service there as well. So as servers are added to the group, it will automatically spread the traffic load across a wider array of servers. There's multiple different kinds of storage you can patch your instance, both the elastic block storage, and the ephemeral storage, which is the local storage attached to the instance. And we'll discuss these in further detail in just a little bit. So some other important vocabulary to note, both the regions and availability zones. We talked about these a little bit already. We have 7 different physical locations for our regions: Northern Virginia, San Francisco, Oregon, Tokyo, Singapore, Brazil, and Ireland. When you choose to build an AWS application, you always designate a particular physical location by choosing a region. And it's really important to know that all the processing, all the storage that you do is always going to stay confined to that region unless you explicitly move the information from region to region. So different organizations, different applications might have requirements to either stay within or outside of some particular country or geographical area. The region model of AWS gives you the ability to control that physical locations. So regions are for your coarse-grained control of location, and then nested inside of these regions are the availability zones. So the availability zones are the physical infrastructure. Each availability zone consists of 1 or more data centers, and there are always 2 or more availability zones per region. When we design and build these availability zones, we always set them up so that within some particular region, any local failures such as power, cooling, network connectivity, physical events such as floods and earthquakes and so forth, that's going to affect one AZ, we're going to pick locations and physical adjacency to make sure that anything that can affect one has a very high probability of not affecting the other zones in the same region. Therefore, the availability zones are really good for letting you implement fault tolerance. You can use things like auto scaling and the load balancing to spread network traffic out across multiple availability zones. Okay. The next important concept is the instance. So the instance is just a virtual server that you boot in the cloud. You can boot these up in a matter of minutes. As I described already, you always boot these up from an Amazon machine image. We give you a very, very wide collection, thousands and thousands of pre-built machine images, and you can choose either Linux or multiple versions of Microsoft Windows. You can boot these up quickly, so you can very quickly scale capacity up or down. Use both the regions availability zones to put high reliability into your application. And we currently have 13 separate instance types that vary in CPU power, RAM, local disk, network speed, and then, of course, price. So you can choose the instance type that's the best suited to your particular application. People always ask about security, and one of the really important fundamental security components of EC2 is the security group. The security group is the virtual firewall that controls inbound access to your instance. The default when you launch an instance is that there is no security group and therefore no network access to your instance. If you need inbound access for particular network ports and protocols, you can add that access in via the management console. So default is no access, so fully protected from inbound traffic. No traffic can reach it. It's then up to you to configure exactly the ports that you would like to allow access. If you'd like, you can even make that with a finer level of control, and you can put network address subranges or particular addresses, IP addresses in the rule to say that you only want to allow traffic, let's say, from your corporate network or from a partner network to allow to be able to reach your instance. You can have multiple rules and multiple security groups attached to each instance. You also have the ability to create what we call elastic IP addresses and use these. The idea of an elastic IP, this is a fixed IP address you create attached to your account. You can then map this IP address to any instance in a particular region. The flexibility and the beauty of this is that if you choose to switch instances, maybe you're scaling up or scaling down to a larger or a smaller instance, you can retain that same outside view, that same IP address, and simply map it to a new instance. So changing instances doesn't necessitate actually changing IP addresses. So as you can see here, 2 screenshots from the console, allocating address, associated address are actually 2 separate operations. One thing I hope you're kind of picking up through here as we go through, some of the operations that you can do with AWS, and particularly through the management console, used to be things you needed to go to your network administrator, your system administrator, your IT department. Oftentimes you had to file a ticket, maybe you had to wait in line, maybe you had to wait for a long provisioning period. A lot of those things that used to take a long time and were very complex have now been reduced to automated point-and-click operations in the Management Console. Another important component of EC2 is called the ELB, or the Elastic Load Balancer. And ELB is used to distribute traffic across an array of EC2 instances. This is really important as you're scaling up and scaling down. So as you add new servers to your mix, you want to make sure that you're evenly apportioning traffic across all those instances. Another important aspect of the load balancer is that it performs what we call a health check on your instances. What that means is, and it can Okay, I believe we have audio back again. Do we have audio? All right, sorry about that. Okay, believe it or not, when I'm speaking to my laptop, I still wave my hands wildly. It's the only way to actually communicate. And I think I might have accidentally hit the power switch on my headset. So sorry about that. Okay, so back into load balancers. So the idea of a load balancer is you can distribute traffic across an array of EC2 instances. This is really important when you're scaling up and scaling down, because as you add new servers to your load balanced array, you want to make sure that those servers are able to get an equal share of the traffic. The load balancer also plays an important role in availability, in that it is able to perform health checks on your instances. What you do when you create your load balancer, you configure in a URL for the load balancer to ping on each of your instances. It will check that every at a configurable time interval. And as long as that ping responds in a configurable amount of time, the load balancer will then assume that your instance is healthy and is able to receive and to deal with traffic. So the load balancer will ensure that traffic only goes to healthy instances. And you can also configure a set of ports into the load balancer if you need to do HTTP, HTTPS, and so forth. Another important aspect of the service is called CloudWatch. CloudWatch tracks and stores both AWS and user-defined metrics. Stores those in either a 5-minute or with an option, you can do also 1-minute resolution. Stores these metrics for a period of 2 weeks. You can view these metrics in the Management Console. You can use them to detect issues, and you can also use them to raise various alerts and alarms. Okay, the next important service to know about is called Auto Scaling. So Auto Scaling is driven by the metrics that are stored in CloudWatch, and it's used to control the number of EC2 instances that are running. Based on these metrics, you can decide to scale up or scale down. Unlike the other services I described so far, which all have an interface in the console, the current Auto Scaling UI is all command line only. That's something that we will probably remedy at some point in the future. Important aspects of auto scaling are the collection of instances that it's managing. So now we go from thinking about single instances to a collection or an array of instances. Once we have that auto scaling group created, we can attach a rule that basically says, Under these conditions, I'd like to add more instances. Under these other conditions, I'd like to remove some instances from the auto scaling group. So once you decide on what metrics you'd like to drive your scaling, let's say CPU load, network traffic out, and so forth, you simply create these rules, attach them to the scaling group, enable the group, and then the group will then scale up or scale down as needed in response to changing conditions. And then finally, one very important service is called Elastic Block Storage, or EBS. EBS allows you to create and manage virtual disk volumes. Each of these volumes that you create can be anywhere between 1 gigabyte and 1 terabyte. You create the volumes with the dialog shown on the left. After you create that volume, you can attach it to any of your instances in a particular availability zone with a second dialog. And then you use it as if it was a local file system. However, if at any point you change instances, you can detach the volume from that first instance and then reattach it to the second one without making any changes, with no backups, no restores, and so forth. With EBS, you also have the ability to very easily do snapshots and restores. If you're in the console, you can simply click on a volume, create a snapshot, assign it a name and a description, and that snapshot is stored with extremely high durability in Amazon S3, which is a storage system. Once you have these snapshots, these are your backups. You can use these snapshots to restore to a fresh volume. So at any point, if you have a server, you've got several volumes attached, you say, I'd like to make a copy of those volumes, snapshot them, restore them to fresh volumes, and without having to mess with tapes or command lines or anything like that, you're able to copy disk to disk with the snapshot in the middle. Okay, so now what we've done is we've really done essentially a bottom-up description of the EC2 side of the Amazon Web Services. I like to build things with Legos, and so there was kind of a natural model here. We started out by talking about all the different kinds of parts there. So we have the upper picture, just a whole bunch of different building blocks and different parts we can put together. However, sometimes we want to really go at a higher level, and we want to say, can we have something that's already all put together and more ready to use? So we have a service to help you do that. It's called the AWS Elastic Beanstalk. The idea of Elastic Beanstalk is to make it easier for you to deploy and manage your applications inside of AWS. There's a couple of different common industry terms for this, sometimes called an application container or a platform as a service, which some people like to call a PaaS or PaaS. The idea here with Elastic Beanstalk, you simply create and upload your application. The Elastic Beanstalk takes care of managing all those detailed services that we talked about earlier in the presentation. It's going to take care of launching enough EC2 servers for you, the capacity provisioning. It's going to set up all of your load balancing. It's going to have a set of auto scaling rules and the auto scaling group in place for you. It's going to monitor your application health using CloudWatch. So I talked to you first about all these different parts, and now what I'm saying is if those parts are the way you'd like to build your infrastructure, that's awesome. We have all those parts for you. If you'd like to take a more application-oriented view of your infrastructure and you simply want to worry about creating the application, Elastic Beanstalk will worry about all those infrastructure concerns on your behalf. Elastic Beanstalk currently supports 3 different language environments: .NET, PHP, and Java. So this really addresses 3 different developer types. If you're using .NET, or if you're using any of these environments, we offer language-specific SDKs for each environment, for .NET, for PHP, and for Java. We have toolkits for Visual Studio and for Eclipse. And then for each of these environments, we like to try to use whatever is the most native appropriate deployment model. So if you're building for .NET, you can build in Visual Studio and upload with Microsoft Web Deploy to a Windows and IIS environment. If you're building with PHP, you can use Git, a very popular source code control system, and you simply use a Git push command to upload your code to a machine running Linux, Apache, and PHP. On the Java side, you use Eclipse. You upload your compiled WAR file, to an environment that's running Linux, Tomcat, and Apache. So the same Elastic Beanstalk environment gives you the choice of 3 separate programming models and environments. Here's the basic development process with Elastic Beanstalk from the top left. You develop and test your application locally. You then deploy it to Elastic Beanstalk. You can test it remotely. You can look at log files, make changes, do continued deployments. As you'll see when I demonstrate this to you, each of these deployments is actually just a matter of seconds. So the edit, test, debug, fix, deploy cycle is very, very rapid. At the point when you've done all your testing, you're satisfied that your application is running as expected, you simply deploy to production. Your application is ready to go. So let's walk through the steps here, and then I'm going to actually switch over to my browser, and we'll do these live on the fly for you. We create some code. In this case, I created a PHP application, simply index.php, which is going to be the default application if I reference the application. I initialize my directory with the git command, git init. I add all the files in that directory to git, and I do a simple git commit to do my initial check-in. I then go to my Management Console with just one more browser tab. Okay, so now we have the AWS Management Console. You should see that. So I have the Elastic Beanstalk tab selected. I can choose from currently 3 separate regions Elastic Beanstalk is available. And I can manage multiple separate applications from within the same console. And those are always chosen from the menu. I already have an application that I created called My First Elastic Beanstalk Application. And it's currently up and running. And it's available at this URL. When I created the application, I let it use the default URL. So it's this long string right here. All right, so here is my application URL, and I can go ahead and refresh that. You can see it simply says, hello world. Now let me make a quick shift over here to my development environment. So all I have here, I have a terminal window up and running. I have Emacs running inside that terminal window. In the bottom left, I have a shell, and in the top left, I have my PHP code. So I am going to make a quick change to my PHP code. I'm going to change it from hello world to hello amazing world. Okay, there we go. I'm going to take that. I'm going to check that in. I check in that change. And then I just do one simple command. I do git aws.push. And this is going to take any changes I've made and committed to Git. Those changes are going to be pushed up to Elastic Beanstalk. We'll go back to the Beanstalk console. And when I'm in the console, one of the important tabs in my application is called the Events tab. So when I go to the Events tab, you can see that if we look at the recent timestamps, there's 3 recent events. Environment update is starting, deploying version, and then waiting, new application deployed, environment update completed. So in just the space of less than a minute, I was able to push those commands. And if I go back to my tab, there's my change I made. You can see it now says, hello, amazing world. So Elastic Beanstalk has already taken care of all of the more complex aspects of setting up my environment for me. Let's go review what those all are. So we created the application. We waited for that application to launch. So in the process of actually creating everything, what really happened? We'll go back to the console. We'll scroll down to our event list. We'll get that all the way down to the bottom. At the point when I launched my initial Elastic Beanstalk application, it created a security group. It created a launch configuration for my auto scaling. It created a load balancer. It created a auto scaling trigger. It waited for my instance to launch. When the instance launched, it was added to the load balancer. It created some health checks for me. It put all the pieces together for me. So instead of having to go into the console, manage each of these individually, Elastic Beanstalk has taken this application level view, this high level view for me, and taken all the more kind of mundane concerns about hosting an application away from my purview. Now, if I want, as I'll show you in a little bit, I still have full control over those other details. Okay, I'm just going to flip through these slides quickly. I've found that when you're doing online demos, it's always really important to have everything backed up and available as slides, just in case. But all these things work just fine for us. We showed you Hello World. So one really important aspect of Elastic Beanstalk is that you still have a lot of control of the different aspects of how your application is run. The default configurations, the default settings, those are all very appropriate for a wide range of application types. However, if at a certain point you'd say, I'd like to have a little bit more control, you have the ability to lift the hood and to start making changes to the configuration. So you can go from a fully managed environment where Elastic Beanstalk has already made all the decisions for you, to an environment where you can exercise individual control over different parameters. We'll go back to the console again. And you can then go to the environment details. And we can look at logs and monitoring. And then we can edit configuration. So we can say edit and load configuration. And here we have control of all the different aspects of that. Okay, back in the audio again. Let me plug in my audio here. Looks like something's going a little funny. Okay, I've gone from wireless audio to wired audio. Hopefully that's going to work a little bit better. Okay, so in this configuration, we can control auto scaling parameters, the number of instances that we're allowed to scale up to, and so forth. We can control when we get various notifications about important events on Beanstalk, and we can control container parameters such as where the log files go, different access keys, and so forth. So as you can see with Elastic Beanstalk, you start out in a very, very simple mode. You simply upload your applications, but then you have full control as things change and as your requirements become more complex. Okay. Okay, so we've pretty much gone through all the most important details of Elastic Beanstalk, and that was just about on the time I expected. Before we do switch to question and answer mode, I do want to make one really interesting aspect of AWS known to you. And that's called the AWS free usage tier. if you create a brand new AWS account, you have access to this amount of free AWS usage on a monthly basis for the first year that your account is in existence. So you get 750 hours per month of both one Linux and one Windows server. So that's enough to actually run that server continuously for the month. You get a load balancer, block storage. You get DynamoDB, which is our NoSQL database. You get quite a bit of services for free, with the idea being you can get some experience with AWS before you even need to spend any money. If you go beyond any of these limits, we'll simply charge your credit card for the amount that's beyond those limits, and at the end of the year, you'll then switch to a paid account. If you're building an application and you're concerned about how much you're using, you can log into your AWS account at any time. You can see how much you've consumed to date. And a relatively new feature that we have, you can also set billing alerts. So based on any of these services, you can say, if my estimated bill for the month exceeds a certain dollar figure, you'd like to get an email address and an alert that tells you that you are exceeding your expectations. So let's go ahead and switch to a Q&A mode. And I'm going to pull up the chat here. Let me pull up the chat. Okay, so let's see. Go ahead and start entering your questions into the chat. I'm just going to mention you by first name, and then I'll answer your questions on there. Let me see what I've got here so far. Okay, I have a question about, can I share some stats about various deployments by market share or .NET, PHP versus Java? I don't actually have those available to me. I know that our customers do experiment with a wide variety of different languages. We started out with Java, and that was our first environment that we supported. After that, we added the PHP support and then the .NET support in response to requests from our customers. The expectation is that over time we will continue to add more languages and more languages and more environments to Elastic Beanstalk. Okay, let's see. Mike asked, he said, you mentioned testing and then pushing to production. How do you isolate an application state to testing only before deploying? So one thing I didn't show you too much with Elastic Beanstalk is that within a single application, you have multiple separate environments. And at any given time, you can have any one of those environments running. And so with that, you would simply be able to have a test environment and then a production environment, and then have those running separately. Okay, let's see. A question about how easy it is to deploy your Rails application. We don't currently support the Rails environment or the Ruby language. As I said before, we do expect to support additional languages and environments over time. Okay, so Mike, I see you asking again about testing an environment. Let me see if I can explain this a little bit better here if I pull up the console again. Okay, so I have there's really a two-level setup here. At the outside, I have an application, and I can have multiple applications managed by Elastic Beanstalk. And then inside of that, I can have multiple environments, and I can have several of these environments running concurrently. So if I were to say, launch a new environment, this would be essentially another deployment of this application. So I could have one for production, another one for development. And then each of these different environments has access to all of the different versions of code that I've updated. So if I go to the Actions menu, I can actually say deploy a different version. And you can see that each time that I did a git push, I can see the git identifier for that version that was pushed there. So I can roll back to any of these previous versions by simply selecting it from the menu. I don't know Git really well, but I assume that there's a way to put a actual descriptive name on there as well. So I can deploy any of these versions to each of my environments for a particular application. So I might have one environment that's my dev environment, a separate one that's my pre-production environment, and a third one that I'm using while I'm doing functional testing. I can create new environments by simply saying launch new environment. I can set the name, the URL, and so forth. And I can make that based off of any one of my existing application versions. So all that's managed very easily within the Beanstalk environment. Okay, let's see. There was a question. I'm not quite sure I grasped the question. It says, can we switch from Beanstalk to the underlying Amazon Web Services? And yes, you can. So you have full control of what's going on in Beanstalk. As I showed you, you can go in through the console, and you can control individual configuration details out of each of the services. So you have that full level of detail. And so you're able to go essentially beneath the covers and do that. If you want to take control over and you want to say, I don't want Elastic Beanstalk to even manage the application at all, there is a way to even disconnect Beanstalk from the resources that you have created. Okay, another good question. Can we use Git with the Java environments? Let's see. I am about 95% sure that you can do that. I would have to check offline in order to be 100% positive. Nicholas, if you want to send me some email, I would be happy to research that offline for you and get back to you. We have a question about, is the AWS service as scalable for Europe? So we currently have a region located in Ireland with multiple availability zones. And from Ireland, we've been serving up our European customers for several years now. So definitely scalable and available for Elastic Beanstalk use. We have a question about two of our other services that I unfortunately didn't give a whole lot of attention to. We have two messaging services that are both really interesting for building complex applications. One of them is called SNS, the Simple Notification Service, and the other one is called SQS, the Simple Queuing Service. Both of these are different types of messaging services that become very, very handy as you start to think about connecting together different parts of a large-scale application. SQS, the Simple Queuing Service, uses message queues. The message queues will buffer messages, and so if you have a situation where you're building, let's say, the classic producer-consumer model, where you have a producer that's putting a work product into a message queue, and you then have someone else, another application, pulling information for that message queue. Maybe they don't run at the same time, so maybe some work is going to stack up in the message queue, and maybe it's going to take the consumer some time to catch up. The Simple Queue service allows you to build this producer-consumer architecture. You can have a single application can be writing to the queue, and multiples can be reading. You can have multiple writers and a single reader, and so forth. So all the variants. The queue service is very, very scalable. You can do as many messages as you'd like and any message rate as needed. The Simple Notification Service is slightly different. The Simple Notification Service, or SNS for short, is a publish and subscribe style message service. So whereas SNS uses what's called a message topic name. So you create a message topic. So maybe you have a news topic and a sports and a weather topic, let's say. Your applications can then subscribe to these different topics inside of SNS. And then when you publish, another part of your application publishes to a topic, the receiving applications are notified within a very, very short amount of time, a small number of milliseconds, basically, that something has been published to a topic. So SQS is good for buffering between different parts of your application. And then the SNS is good for distributing information across different parts of your application. If I don't get to the detail that you'd like on any one of these particular services, you can go to aws.amazon.com and get additional information about them. All right, another good question from Nicholas. Can CloudWatch watch all AWS services? Is there some KPIs per service you can cover? So a number of different services export their metrics into CloudWatch. Let me actually bring that up in the console to show you. It's actually really helpful just to simply show you how these things work. So we'll go back to our management console. So the way CloudWatch works is that the different services that I have running and that I have instances of are going to be sending metrics to CloudWatch on a regular basis. So let's say, for example, okay, here's a good one. So this is a metric that I have collected on one of my servers. So on this particular one, I have it set up if the network out, if my server sends more than 6 megabytes of traffic per second for more than 5 minutes at a time, that's kind of surprising to me because it's my personal server. It's just not all that busy. So I set up an alarm to let me know if that were to happen. So CloudWatch is able to watch for network traffic. Another alert that I have with CloudWatch is I have an alert to make sure that I'm not spending more money than I anticipate. So we recently, just last month, introduced a new feature we call billing alerts. And with billing alerts, we publish the actual amount of money you're spending through AWS to CloudWatch. So I know that I generally spend about $40 to $45 per month on my personal AWS usage. I have a lot of data stored. I have a couple of servers running. So I set up an alert that says, if my estimated charges go above 40, I would like to be alerted to that fact. So I set this up so I know for sure I'd be alerted at close to the end of the month. If we look at the actual usage graph here in the bottom right, you can see that as we got closer and closer to the end of the month, my charges for the month were approaching $40. And slightly before the end of the month, they actually crossed that $40 threshold. And so I did receive a notification from CloudWatch letting me know that I had actually crossed that billing threshold. This is a good way to know for sure that you're not going to get a surprisingly large bill. Now over here on the left-hand side, you can see a number of different services that I have and the fact that they all have metrics available to them. So let's say we click on EC2. We have a number of different EC2 metrics available. For example, CPU utilization. You can see the graph there that my CPU is not all that busy. It has occasional peaks up to about 50 or 60% every 2 hours or so. We can look at disk reads. You can see that my disk reads are actually not all that busy and doing a very modest amount of network traffic in and network traffic out. Again, I can watch all these. I can set alerts. I can get monitored on any of these as needed. For billing, I can actually look at each of the different services, and I can say I either want to get a notification on the full estimated charges or the charges for any particular service. This is a relatively new feature and one that our customers were very excited to hear about. With CloudWatch, I also have a dashboard. I can see the status of all my alarms, and I can see some of the more interesting statistics of my overall resource utilization. All right, let's see what are the questions that we have here. All right, looks okay. I just power back my headset one more time. I'm not quite sure why it's cutting out today. It's been very reliable for the last year, but suddenly it seems to be shutting it down on its own. Okay, so the question was, can you use auto scaling only through metrics from CloudWatch? So there's really three separate types of metrics in CloudWatch. We have the metrics for the various AWS services. We have the business metrics, which are the billing values that I've shown you. But the third one is that you can also create user-defined metrics in CloudWatch. I'm not sure if I have any right now. Let me check and see if I have any. I think I might have set some up. Yes, I did actually. Do I have this here? No, I actually used to be pumping some of my own metrics into CloudWatch. I think I must have shut that down. So using the CloudWatch APIs or the command line tools, you can pump your own metrics into CloudWatch where they'll be stored for 2 weeks, just like all the other metrics. And you can then use those metrics to drive auto scaling decisions. And that looks like all the questions I see. Any last one or two questions? Happy to accommodate them. Okay, not seeing anything else coming through. Oh, here we go. Here we go. Oh, can we talk about MapReduce? Wow, good question from Bullet. All right, so MapReduce would probably take an hour all by itself to fully describe. So it looks like a couple people want to hear all about that. Ooh, interesting. Wow, so let me think of how I can summarize MapReduce in just the few short minutes that we have left. So MapReduce is a very advanced parallel programming model. Was originally invented by Google, and then Yahoo did an open source implementation that they call Hadoop. A few years ago, we took that Hadoop implementation, and we built a service we call EMR, or Elastic MapReduce. So much like Elastic Beanstalk takes away a lot of the necessity to worry about the lower level details of hosting an application, the Amazon Elastic MapReduce makes it super easy to launch and run and monitor a Hadoop cluster. We can do that all through the Management Console. So Elastic MapReduce is great for doing large-scale parallel processing, where you know that you're going to have a lot of data coming in, and you know that the kinds of processing that you want to do on that data, you can easily process subsets of the data. So that you can, if it's text files, maybe you can break that text file up into blocks of 10,000 lines at a time, run each of those on a separate processor. That's generally called the map phase, and you can run a whole bunch of those in parallel. And then you would be able to join all those results together in the second phase, which we call the reduce phase. So if you didn't have the high-level interface of Elastic MapReduce, you need to have a big array of hardware. You need to install the software. You need to just worry about the care and feeding of all that hardware. With Elastic MapReduce, you have the ability to simply create a new job flow. We have some sample applications. We could choose, for example, a word count application. We can point to some input data, tell it where we'd like the output data. And then we can actually say how many processors we'd like to run on against that data. So instead of having projects that run longer and longer and longer as we add more data, we can simply scale up and add more EC2 instances and just add additional parallelism to the system. Given that I've seen a lot of interest in MapReduce, I'm actually going to talk to the folks at AT&T, and perhaps we can do a separate session on Elastic MapReduce. It would be easier to do it justice in a session all of its own. Okay, looks like we are not seeing any more questions. Oh, let's see. Let's see, question of advantages versus disadvantages. Let's see, can't think of any big disadvantages offhand. We have a lot of customers that run what I would think of as pretty large-scale jobs on Elastic MapReduce. When I think of large scale, I'm generally thinking in the order of hundreds to thousands of parallel processors running at a time. At that point, I think customers really start to appreciate the fact that they don't have to worry about owning all that hardware, about managing it. They don't have to worry about, after having acquired it, actually being able to keep it busy to make sure it's economically viable. They like the fact that they can launch the job, get the output, shut the cluster down, and not have any further worry about the economics of that. So you're simply paying by the hour for the processors that you use in that cluster. Also, I know that customers have told me that they love the fact that they might launch one job, maybe they're doing some analytics on that job, and while it's running, they say, well, you know what, we have some other ideas, some other analytics we'd like to run, and they launch a second job or a third job, and they don't have to worry about running out of resources. If you talk to people that run their own internal clusters, the clusters are never big enough, they're always too busy, or they're sitting there 100% idle, doing absolutely nothing. They seem to vacillate between doing nothing and overcommitted. So the cloud-based model lets you get around that because you can get as many resources as you need from the cloud. Looks like we are just about at the top of the hour, and I really appreciate your taking your time to listen and to ask questions. You've got my email address there on the screen. Let's see. Last question says, are you going to be at Mars? I'm not quite sure. Definitely not Mars, the planet. If there's another thing called Mars I don't know about, I still don't know where that might be. But Nicholas, feel free to send me some more information about that. I'm going to sign off now, but again, thank you for listening, and perhaps we'll be able to chat in person. Bye-bye.